Imagine opening a farm that raises lions for meat. Every morning, trucks arrive carrying meat. Not for customers, but for the lions. Truckloads of edible food go in. Years later, a much smaller amount of lion meat comes out. The delivery driver may also prefer that the customers stay behind two fences. And lion meat is not magically inedible. Humans already eat plenty of predators, especially from the ocean. So, why did our farms fill with cows, pigs, and chickens instead of lions and wolves? Because the hardest question was never, can humans kill it? It was, can humans make the same meal happen again tomorrow? The real mystery is not whether humans have ever eaten predators. Certain land predators and omnivores are eaten in particular cultures and conditions. Many familiar seafoods are hunters that chase smaller animals for a living. The deeper question is why large land predators almost never became staple livestock. A quick distinction matters here. Predator describes behavior, carnivore describes diet, and apex predator describes position in a food web. Those categories overlap, but they are not interchangeable. This video focuses mainly on large land predators as potential livestock. Taste matters locally, but taste alone cannot explain such a broad historical pattern. Once edible is separated from practical, most food animals face three harder tests. Can we get it without losing more than we gain? Does feeding it make sense? Can we produce the same food again tomorrow? Picture a chicken quietly laying eggs before it ever becomes dinner. It can provide food repeatedly, breed under human control, and produce new generations quickly. A large predator usually works in the opposite direction. It consumes expensive food for years before most of its direct food value arrives at slaughter. One calculation measures a single meal. The other measures an entire lifetime of cost. So, begin with the first test, obtaining one predator at one time. Before anyone worries about feeding a predator, they first have to catch or control one. Prey animals are not harmless targets either. A charging bison can gore a hunter. A kicking horse or an angry boar can end a hunt in seconds. So this is not simply safe prey versus dangerous predator. It is a question of return. How much food does the risk, time, and effort actually produce? Large land predators carry several disadvantages. Their natural weapons make handling mistakes especially costly. Many also resist crowding, confinement, and controlled breeding. Some live alone or defend wide territories. Even social species remain difficult to manage safely at livestock scale. Finding one may require days of searching for a single dangerous target. Now, compare that with a herd grazing together in an open valley. One search may reveal several animals at once, visible and countable. The risk is spread across more potential food. A dramatic hunt for one predator rarely wins that calculation. Survival does not reward the most impressive kill. It rewards food gained, while preserving hunters, tools, and time. Catching one predator is difficult enough. The larger problem appears when people need the next one. Even a successfully hunted predator has already consumed an enormous food budget. Every animal burns energy simply by moving, breathing, healing, and staying warm. Only part of what an animal eats becomes body mass another animal can use. Feeding edible animals to a predator, then eating the predator, adds another energy-burning step. Return to the imaginary lion farm. Meat trucks roll in every day. A much smaller amount of lion meat eventually rolls out. While the system operates, the lions keep burning fuel just to stay alive. The predator becomes an extremely expensive middleman. The exact cost varies by species and setting, but the basic pattern remains. Hunting one animal is different from building a system that reliably produces more. Domestication does not begin with taming one unusually calm animal. It begins when a breeding population can tolerate people, confinement, and repeated reproduction. An animal may be trainable as an individual and still be terrible livestock as a species. The important traits must survive across many animals and many generations. That system needs animals that fit a repeatable process. Can they breed under human control? Can many individuals be managed together without constant danger? Can people feed them with resources that do not cost more than the final food? Do they grow or reproduce fast enough to justify the wait? Chickens perform well because they are small, social, fast-breeding, and able to lay eggs. Sheep, goats, and cattle turn grasses and other plants humans cannot digest into useful food. They convert resources from fields, hillsides, and scrubland into products people can use. Pigs can eat varied resources and adapt to many managed environments. None of these animals is perfect or automatically sustainable. They are simply workable under enough conditions. A large land predator usually needs animal-based food and remains difficult to contain. It also provides little practical secondary food comparable to eggs, dairy, or wool. After years of costly feeding, most of its direct food value still arrives only at slaughter. Common livestock did not succeed because of one magical trait. They passed several practical tests at the same time. That seems to settle the question on land. Then, the ocean produces a very inconvenient exception. Tuna hunt, salmon hunt. Many fish people regularly eat are predators. If predators make poor livestock, why are predatory fish so common on menus? For much of human history, people harvested many of them from food webs they did not have to feed directly. Humans did not breed every smaller fish those predators consumed. Nobody delivered each meal by hand. For years, nature paid the energy cost through sunlight, plants, plankton, prey, and countless earlier meals. Humans usually paid only for finding and catching the final animal. That cost was not ecologically free, but it was outside the farmer's feed bill. The first test can also become easier in water. Aquatic predators may gather in large, dense groups. One net can catch many fish, instead of one dangerous animal at a time. That does not make ocean predators perfectly safe, efficient, or unlimited. It shows that harvesting wild animals is fundamentally different from raising livestock. Some predatory fish are farmed today, which may sound like a contradiction. It is not, because farming them simply makes the feeding cost visible again. Someone must supply the smaller fish, fish meal, or other feed that supports their growth. The obstacle was never the label. Predator. It was the total system required to produce that animal repeatedly. System costs explain the broad pattern. They do not decide every item on every local menu. Taste still shapes what people enjoy. Some predator meat is described as tough, strong, oily, or unfamiliar. Elsewhere, similar meat may become a valued local delicacy. Taste explains particular preferences, not the entire worldwide pattern. Culture adds another layer. Humans classify animals as food, companion, threat, symbol, sacred being, or protected wildlife. The same species may be ordinary food in one place and unthinkable in another. Once a society builds habits, tools, recipes, and laws around that category, the distinction can feel completely natural. Biological caution matters too. Although it is never a simple predator versus prey rule. Some wild meats can carry parasites and require careful handling and thorough cooking. Some long-lived aquatic predators can accumulate contaminants, all from their environment. That does not make every predator dangerous. It also does not make every prey animal automatically safe. Bear, alligator, shark, and other predatory animals still appear on particular menus for local reasons. Practical systems create the broad possibilities. Taste and culture help decide which possibilities become normal. Now, picture an ordinary supermarket meat counter. Chicken, pork, beef, lamb, and fish sit in tidy packages. They look almost boring, but every package represents a long chain of solved problems. People learned how to obtain the animal repeatedly. They learned how to feed, breed, manage, process, preserve, and transport it. They also learned how to make later generations recognize it as normal food. A single cut of meat is not merely the end of one animal. It is evidence that another similar cut can appear next week or next season. That quiet repeatability is the hidden achievement behind the counter. Large land predators usually failed those practical tests before taste could become the deciding factor. They were costly to obtain, expensive to feed, dangerous to manage, and poor at providing predictable returns. Aquatic predators often reach the menu because humans harvested food webs nature had already built. Culture then selected which available animals felt acceptable enough to eat. This does not mean every modern farming or fishing system is efficient, ethical, or harmless. It only explains why certain species entered repeatable food systems in the first place. So, do humans eat predators? Clearly, yes. The real pattern is that large land predators rarely became staple livestock. They tend to fail several tests at once. Catching them is risky. Feeding them wastes valuable energy. Managing and breeding them is difficult. Producing the next meal remains uncertain. Taste, culture, parasites, and contaminants shape specific cases, but they usually modify the deeper practical pattern, rather than create it alone. Remember the imaginary lion farm? It does not fail because lion meat is magically inedible. It fails because almost every step before dinner is worse than the alternatives. Human food history is not mainly a record of which animals people were brave enough to kill. It is a record of how people turned uncertainty into something repeatable. A lucky hunt feeds people once. A working food system creates the chance of another meal, tomorrow. The animals on our plates are not simply the ones humans could kill. They are the ones humans learned to turn from a lucky meal into food for tomorrow.